Where is everybody? Last time we talked about all of the civilizations that could exist in the galaxy. There billions are possible, and the question is, why haven't we seen any of them yet? Enrico Fermi, well, let's let Hank tell you.
In 1950 at Los Alamos, a scientist was talking with his friends, and the conversation had them all fully engrossed about this universe that almost has no end. And as they were all about to return to their study, Enrico suddenly shouted, "Where is everybody?" And he sat down and did a few simple calculations that indicated we should have been visited thousands of times at least, based on his estimations. And that's the Fermi paradox. If they're out there, why don't we hear him talk? The galaxy just keeps on spinning with 400 billion stars in it. And I just can't believe that we could be unique when there's so much space in this galaxy. Oh, I want Pandora's box to be open, but instead we're stuck in Fermi's paradox. Well, there are dozens of ways this paradox may be resolved, and you probably can think of some yourself. Maybe advanced technology rarely evolves, or maybe God sent them all to hell. Or maybe that technology leads to its own destruction. Or maybe species lose interest in reproduction. Or maybe they're just afraid of what we'll do when we find out, so they're hiding until we grow a bit and don't have the same tendency to frequently freak out. Oh, that's the Fermi paradox. If they're out there, why don't they talk? The galaxy just keeps on spinning with 400 billion stars in it, and I just can't believe that we could be unique when there's so much space in this galaxy. Oh, I want Pandora's box to be open, but instead we're stuck in Fermi's paradox. Well, the question of whether there is more life out there, as far as I'm concerned, is moot. But it appears that the aliens do not use Foursquare, and no, I'm not trying to be cute, because the way that we listen is defined by our ears, and the time that we've been listening, just a couple dozen years. We'll be lucky when we see them, if we notice them at all. Our cosmic phone could be ringing off the hook right now, and we're just not answering the call. Oh, that's the Fermi paradox. They're out there, why don't they talk? The galaxy just keeps on spinning with 400 billion stars in it, and I just can't believe that we could be unique when there's so much space in this galaxy. Oh, I want Pandora's box to be open, but instead we're stuck in Fermi's paradox. Oh yeah, we're stuck in Fermi's paradox. Oh no, we're stuck in Fermi's paradox. Oh yeah, we're stuck in Fermi's paradox.
Thanks, Hank. Where is everybody? We know there has to be some civilization, or we know there are places where civilizations could be out there, because we've seen this with the Kepler telescope. Now, we've talked about this before. Kepler, which looks at a single field of view at hundreds of thousands of stars, has discovered thousands of planets, many of them Earth-size. Right? If a little blue dots in there are Earth-sized planets. And if you look at the distribution, there are lots and lots of Earth-sized planets and super-Earths, which could also be habitable. In fact, a recent paper just came out indicating that something like 22% of Sun-like stars harbor Earth-sized planets orbiting their habitable zones. If that's the case, that 22% of the stars in our galaxy have Earth-like planets around them, there should be somebody else out there. Now, Enrico Fermi had calculated that a single civilization, the galaxy just isn't that big. It's really old, and they could have colonized the entire galaxy in just a couple of 100,000 years. So where are they? Now, if you look at our nearby solar system, the nearest, if you figure 20% of the stars have Earth-like planets, the nearest star to us that's Sun-like is this one called ASTR1040, which is about just a little bit over 7 or 12 light years away, because this is ASTR1040 right there. So it's just about 12 light years away. That's the most likely system to have Earth-like planets. Now, the nearest system to us, which is Alpha Centauri, is right here. This is Alpha Centauri. Those are two Sun-like stars in a binary star system. So in principle, those could also have habitable planets, which would be very nearby to us. So there should be some around. The question is, why haven't they visited us yet? Now, Alpha Centauri is right now this closest star to us. In about 30,000 years, Ross 248 will be the closest star to us. And a little bit later, Gliese 445 will be the closest star to us. So there's lots of candidates for potentially habitable systems. And if it's possible to travel through the stars, we should see these people visiting us. Now, reports of alien abductions aside, we have no evidence that we have ever been visited by aliens. So what are some possible explanations? Well, the first one, I guess the main one, is that few, if any, other civilizations exist because they haven't arisen yet. Maybe we're the first. Maybe it's the nature of intelligent life to destroy itself. Maybe it's the nature of intelligent life to destroy others. So there has been a civilization cropped up and it just laid waste to everybody. Or maybe it's possible that life is periodically destroyed by naturally occurring events, and so at any one time in the galaxy there's only one civilization around. Those are all possibilities. None of them are terribly attractive. The other one that I find a little bit more attractive is that they do exist, but we have yet to see the evidence. And there are lots of reasons for this. One is that communication is improbable because of the problems of scale. Now, we can listen to radio signals from across the galaxy, but sending signals is really expensive. Intelligent civilizations might be too far apart either in space or time. So, for example, we've only been searching for a couple of decades for extraterrestrial intelligence. Therefore, if the nearest civilization is 20 or 30 light years away, we wouldn't have heard it yet, just because of the light travel time. It's too expensive to physically spread throughout the galaxy. I mean, we're about on the verge of creating virtual environments that we can just go into and explore, and maybe that's what civilizations do. They just plug in, go online, and stop paying attention to the rest of the galaxy. We may not have been searching long enough. I put that down here. They're too busy online. That's where they're in their virtual worlds. They could be so alien that we don't even recognize them as intelligent life. And it's possible also that they know we're here and they're avoiding us because we're crazy. That's possible. Some other explanations that are put out there. One is that we have been confined to this solar system, and they are studying us. That's called the zoo hypothesis. One thing that Stephen Hawking has suggested is that it may be too dangerous to communicate. As soon as you communicate, these very violent creatures come and wipe you out. So that's why nobody communicates, because it's too dangerous. They could be here unobserved. So I don't know how you would ever prove that, but they could be here unobserved. Or the one that everybody gets worked up about, the evidence is being suppressed, which I just find highly unlikely given the number of cell phone cameras that there are. Why, in this proliferation of cell phone cameras, we have not seen any legitimate sightings of UFOs. We just still have all the fuzzy photographs from the 70s. So we can search for that. We talked before that we can search for extraterrestrial intelligence using radio telescopes and radio emissions, and we discussed how you can contribute to that through SETI at home. Now let's think about another way. What if we were to send a probe to a nearby system? So this is Alpha Centauri, right? Alpha Centauri is a binary star system with two very sun-like stars and one red dwarf. There are planets around these star systems. So if you look at, this is Alpha Centauri BB, it has a planet that orbits its star in 3 days, and you can see how that compares to Mercury, Venus, and Earth. Now this star is slightly cooler than the Sun, so its habitable zone, if there was a Venus around it, its habitable zone, Venus would be right inside of it. So it's entirely possible that since this has one planet, it has more planets, so we could send a probe there to find out. One way to do this would be to notice that we have two stars in proximity to each other with habitable zones around them, and those habitable zone stars, or the habitable zones around those stars, even though they're a binary star system, are stable. This represents the stable orbits of 2 astronomical units. So we've got two stars right next door to us, effectively, 4 light years away, that could have habitable planets. Now, back in this 1980s, a bunch of undergraduates suggested that there was a way to do this, send a probe to Alpha Centauri on the cheap that would get there in just 100 years. And it was just a probe, it was a flyby mission to just fly through Alpha Centauri and see what it looked like. Now 100 years sounds like a long time, but think about it. If they had launched it back in 1987, then it would be almost a quarter of the way there by now, right? And in in 100 years, if somebody had pictures from Alpha Centauri, we'd be really thrilled that we'd sent this project. Project Longshot it costs about as much as a Mars mission, so we skip one Mars mission, we send one to Mars every 2 years, skip one Mars mission and send this to Alpha Centauri, and in 100 years somebody will be able to have pictures of what that solar system looks like. Now if we do that, we would be the first ones to send a probe, and as I mentioned last time, maybe somebody's already done this and sent probes to us. Of course, we haven't sent a probe, so maybe we're just not advanced enough yet. Now, if we want to think about space travel, how incredibly expensive space travel is, we want to look at it in terms of energy, because that really is the ultimate cost of sending the spacecraft. Now, let's just do some quick comparisons here. We have remind us that our typical unit of energy measure is the kilowatt hour. This is something that you probably have seen in your house, a kilowatt hour. A kilowatt hour is 1,000 watts generated in 1 hour. Okay, so watts is a unit of power, hour is a unit of time, so these together are a unit of energy. And a petawatt is 1 trillion kilowatt hours. Okay. So the amount of energy that we need for the Voyager spacecraft, which is this guy right here, to send the Voyager spacecraft at an appreciable speed of light, say 10%, is 0.1 petawatt hours. Right? And we'll compare that in just a second. Now, if we wanted to accelerate Voyager to 0.9 the speed of light, that takes 25 petawatt hours. And if we want to go to 0.99% the speed of light, it's 110. You can see relativity's kicking in. The faster you go, the more energy it takes to go even faster. So this is 110 petawatt hours, right? Now, to put that in perspective, the total 2008 world energy consumption was 143 petawatt hours. So if we wanted to send Voyager at 0.99 the speed of light, we would have to effectively use an entire year's worth of energy to do it. However, if you don't mind going fast, it doesn't take hardly any of our energy to do it, less than 0.1% of the energy that is needed. So if you don't mind taking a little bit of time to get there, and again, this is 0.1c. This means it would get to Alpha Centauri in 40 years instead of 4. So this is about the speed we would have to send Project Longshot. Now, if we wanted to talk about something like the Starship Enterprise, well, that thing's just way too massive. We're talking 50,000 petawatt hours to send it at 0.9 or 0.1, 127 million petawatt hours to send it to 0.9, which is 1,000,000 times more energy than we use in a year. So nobody's flying anywhere in the Starship Enterprise. However, that's the energy that we use on the planet. This is the amount of energy, that's the total annual solar output, 3 times 10 to the 15, which makes both of these numbers small in comparison. So they're big compared to the energy we use on the planet, but they're small compared to the total energy of the sun. So I wouldn't totally rule this out, but I would rule it out in terms of our present-day technology for certain. So one thing I'd like to suggest about the Fermi paradox is that it's possible that we are just now one of the first emerging civilizations. And this is sort of analogous to the Cambrian explosion. About 600 million years ago, most life forms were simple single-celled organisms. And then in just a few tens of millions of years, there was this incredibly enhanced rate of evolution that increased the evolution rate by an order of magnitude, and suddenly there were macroscopic organisms in the ocean, and we eventually got land plants and animals and all sorts of things. So it's possible that we've reached just the time in the galaxy when Earth-like planets are common, and there's enough materials to create habitable worlds, and those habitable worlds are just evolving life, and the civilizations are just beginning to evolve. There's some evidence this might be true, and that's because we can look at the galaxy just like we look at a star and ask where are the habitable regions of the galaxy. And if you think about the galaxy, inside in this very, very star formation rich area down in here, there's just too many supernova explosions going on, so the radiation is too high. Out here, there's just not enough material to make a lot of Earth-like planets because there's not enough star formation to get enough metallicity. And so there's a region in the galaxy called the galactic habitable zone, which has the most likely place to form habitable planets. However, the galaxy also needs time to accumulate those types of habitable planets and the materials necessary to make those habitable planets. So there was a study done a while back, about 10 years ago, at looking at the age distribution of complex life in the Milky Way, effectively asking the question, how long would it take for the Milky Way to evolve to the point where it could make stars and planets like ours? And they did some interesting calculations where they looked at the increase in metals. So you remember metallicity is a measure of how much carbon, nitrogen, oxygen, and things like that that you have. And they looked at how long it took to evolve materials of a given type. Now the sun is right here today, and 0 just as the reference. It's a logarithmic scale. This represents a solar type of metallicity. And so this is the evolution of the types of elements that we need to form Earth-like planets. And you see when the sun is formed, about 4 billion years ago, we get enough materials to form a planet like the Earth. And then we get up into this place where we have a abundance of metals. And then this over here is just showing a distribution, the likelihood of being able to have an Earth over time. And the peak likelihood is right here. And that peak likelihood happens, the best time for that to happen is right around 4 billion years. So it took until 4 billion years ago before we could even have the types of planets like Earth that we find inhabited, or inhabitable at least for us. And they also looked at the probability of surviving a supernova. Early on in the galaxy, there was just too many supernovae going on. And so if we look at the amount of supernova per year, right, this drops off over time. And this is where the sun forms 4 billion years ago. And we get this drop off in the probability of surviving the supernova that gets down to, up to 90% right about 4 billion years ago. So in addition to taking that long to get enough metals to form planets, we had to wait that long for the danger rate of all these giant explosions before things settled down. And so what this seems to indicate is that 4 to 5 billion years ago was about the prime time for making Earth-like planets. So if that's the case, then we can look at the distance from the sun, or the distance that the galaxy, the sun is in the galaxy, the time before the present, and here's the sun where it was formed 4.55 billion years ago, about 8 kiloparsecs away, and that there's a region in this parameter space that's the most likely to form sun-like planets like the Earth around sun-like stars. There was a region early on and close into the galaxy where there were too many supernova. Early on in the entire galaxy, it's too metal poor, and it's still too metal poor far out. Now, as we go further on, we've got too many metals early on, or in the inner part of the galaxy later on. So there's too many metals, so that we don't get any free oxygen to form any water. And then up here, we haven't had time to evolve civilizations yet. So any star that formed here hasn't had enough time. So if we assume that it takes about 4 billion years to get an intelligent species, we should just now be seeing a bunch of civilizations spring up. That's a possibility. The other possibility is something I like to call the flicker model. And what this means is that advanced species, intelligent species, are frequent and short-lived. And so they might last for 100 years or 1,000 years, and then they wipe themselves out. So you can imagine this would be like looking up at the night sky and seeing just a bunch of fireworks or flickering of lights going on and off. There's a civilization that's gone. There's a civilization that's gone. And if it's only around for 100 years, it takes 100 years for that light to pass by the Earth. If we don't happen to be listening for that 100-year period, we never see them. So it could just be now that we have the technology, we can suddenly start to see these things flicker on and off. And while that would be kind of depressing because it would mean that our civilization probably won't last very long, it would at least explain why we don't see very many of them all over the place. All right, so that's Fermi's paradox. My hope and my goal is to search for Earth-like planets that have life on them. My hope is that we will find them within the next decade or so. And I'll just leave you with this last little piece that a friend of mine told me a few years ago. He works for the SETI Institute, and he said that by 2061, we will have searched enough of the galaxy that we will either absolutely know for a fact where the intelligent life is, or we will have very, very hard limits on how rare intelligent life happens to be. So put that on your calendar.